Okay. Before I discuss the interior of the amplifier, I need to list the different amplifier types. There are 4 amplifiers. The first amplifier is the voltage amplifier. The second one is the current amplifier. Third is transconductance. And the last one is transresistance. Transresistance, okay? Let's begin with the voltage amplifier. Let's begin with the voltage amplifier. Let's begin with the voltage amplifier. Okay. So how does the voltage amplifier, what's the interior of the voltage amplifier? It looks like this, Ri. Okay, and we have a dependent source, dependent voltage source, AV node Vi. Here we have Ro. Okay, so this is the interior of a voltage amplifier. So actually, all of this is inside the actual amplifier, if you can visualize it like this. Okay, so now in the question, the instructor when he asks you about the voltage amplifier, he will give you what's drawn in blue. Now you have to connect 2 things. You always have to connect 2 things, the input and the output, Vi, and here there's V output. Okay, you always have to connect 2 things, the input and the output. Let me draw it in red. Now at the output, it's simple, it's always RL. Whereas in the input, you have to connect 2 things. You have 2 options. It's either Norton or Thevenin. It's either voltage source in series with a resistance or a current source in parallel with a resistance. So what are we going to choose here? Actually, it depends on this. Look at this. If this is Vi, then if the voltage source depends on a Vi, then here you have to connect the Thevenin form. So here we have to connect RS and VS. Okay? Whereas if you have a source depending on a current, then here you have to put the Norton equivalent at the input. Okay? Before we continue, let's first understand the namings of those resistors, the namings of those sources. What are they called? Let's pick a nice color. Let's pick brown. This is called load resistance. It's trivial. Load resistance. Load resistance. Okay. This is the output voltage. The output voltage. Why am I explaining the namings? Because sometimes in the exam, when he gives me a question, he does not place the actual number on the circuit itself. He gives you the question as a paragraph. He says, for example, the output resistance is 5 kilo ohm. So we need to understand what is the output resistance. Okay. So here we said it's output voltage, and RO, as you have guessed, it's the output resistance. Okay. RI is the input resistance. VI is the input voltage. RS is the source resistance. Vs is voltage source, and the last variable that needs to be defined is AV naught. Now what is AV naught? You might guess that it's the voltage gain. Well, no, it's not the voltage gain. Why? Because the voltage gain is AV. AV is reserved for V output divided by V input, whereas AV naught is something else. Its name is open circuit voltage gain. Open circuit voltage gain. This is a constant number. It will be provided for you. It's not something that you have to calculate. Voltage gain. Okay. So if he asks me find the voltage gain, what should I do? Find the voltage gain. We know from the earlier explanation that voltage gain is AV naught, right? It's AV. AV is equal to V naught over V input. It's V output divided by V input. My advice to you to approach this kind of question, you always start from the numerator. You always start from the numerator, which is the output. And then you try to reach that denominator. So you start with the numerator and you try to find an equation that relates the numerator with the denominator. Okay, so where's the output first in the circuit? It's in here. This is the output. Okay, where's the input? This is the input. So now try to find a relationship between the output and the input. Now V output is very far from V input, but if you notice there's another V input in here, right? So what are we going to do here? How can we relate V output to V input? We can just do a voltage division. Why? Because we have a voltage source. There's a voltage source in here. There's a resistance and another resistance in series. So we can just do a voltage division. So V output is AV naught multiplied by V input, AV naught multiplied by V input multiplied by the resistance that I am on, RL, divided by the total resistance, RL plus RO. Okay, but we're not done yet. Why? Because he asked me for the voltage gain, which is VO divided by V input. What you found so far is V output, so you need to divide V output by V input, which is equivalent to AV naught RL divided by RL plus RO. Now this is the final answer. What is the unit? It's V over V. Okay, now if he asks me to find the overall voltage gain, now the requirement is something else. Find the overall voltage gain. Now the requirement is something else. Why? Because he asked me for the overall. What is the overall? Overall is V naught divided by Vs. What the voltage gain by itself is only V naught divided by V input, but now he wants V output divided by the Vs. You see the difference? This is the overall. Let's continue. So where do we start? We always, as I said before, we always start from the numerator. Which is V output. Now try to find a relationship between V output and Vs. Now definitely there's no one equation that you can directly represent V output and Vs. Okay, why? Because those are two different circuits, a circuit on the left and a circuit on the right. So we can approach this as in two steps. First, you will find V output in terms of V input, and then connect and then find V input in terms of Vs. Then take this equation, the equation that you found in here, and plug it into the equation that you found to the right side of the circuit. Okay, Maybe it's not clear, but when we approach it, it will be clear enough. Okay. So first, we said we need to find V output in terms of V input, and then V input in terms of Vs, and then plug them into each other. So what is V output in terms of V input? We already found it in here, right? It's in here. So V output in terms of V input is AV naught multiplied by the V input multiplied by RL divided by RL plus RO. Okay. So now what is V input in terms of Vs? It's voltage division again, because we have a voltage source and two resistances in series. So it's Vs multiplied by Ri divided by the total resistance. So Vi in terms of Vs is, it's Vi equal to Vs multiplied by Ri divided by Ri plus Rs. See? It's Ri divided by Ri plus Rs. Okay. So what are we going to do now? We're going to take all of this and plug it into where? The input. Okay. Let's see now what will happen. You will get V output is equal to AV naught open brackets Vs multiplied by Ri divided by Ri plus Rs, close the square brackets, and then go back to the earlier equation, RL over RL plus RO. You're not done yet. Why? Because he asked me for V output in terms of Vs. What we found so far is V output. So you need to divide the Vs term here. So my solution is V output divided by Vs is equal to AV naught multiplied by Ri plus Rs multiplied by RL over RL plus RO. Okay, this is the final answer. And the unit is V over V. Great. Now let's move on. Before we move on to the second type of the amplifier, let's find the ideal characteristic of this amplifier. What are the ideal characteristics of this amplifier? Now, the ideal characteristic is, in order to find the ideal characteristic of this type of amplifier, you can either play only with Ri and Ro. Okay? You can only play with Ri and Ro. What do they want now? They want the ideal case. What does ideal mean? It means that whatever is being inputted into the amplifier, it needs to be outputted. So Vs needs to propagate to the V output. Okay? Currently, V output is not equal to Vs. As you can see here, V output in terms of Vs, it's multiplied by other factors. There are other terms in the equation. Okay? So we need only V output in terms of Vs. What can we do? First, Vs needs to propagate into purple. First, Vs needs to propagate into Vi. How can we do this? What should happen to Ri so that Vi is equal to Vs? We have two options. It's either short circuit or open circuit. Let's see here. We have a voltage source, Rs, we can't play with it. This is a short circuit. And we have another voltage source. This is Rs, and an open circuit. Okay? In this case, what is Vi? And in this case, what is Vi? In this case, Vi is equal to 0 because you're measuring the voltage drop across a short circuit. It's always equal to 0. Whereas here, there's no current. If there's no current, the resistance is useless. Hence, Vi is equal to Vs. This is Vs, of course. Okay, so we need Ri to be open circuit for Vi to become equal to Vs. Now, moving on to the next Oops. To the next side of the circuit amplifier. Here we need, now we have reached to VI. VI is VS. Now we need to propagate this VI into V output. How can we do this? We can play only with RO. We have two options. We have to make it either short or open again. So let's try it. I ran out of space. Here we have our dependent source, right? And we have our RO. It needs to be either short circuit or open circuit. This is my V output RO. Okay? And this is the other scenario where it is open circuit, V output, and this is RL, not V output, RO. So what's V output in this case? V output in this case is equal to this source, right? Because they are in parallel. Whereas here there's no current, so RL is useless and V output will become 0. Okay? Here V output is equal to AB naught VI. So the solution is for RO to become short circuit. RO needs to become short circuit for it to propagate to the output. Short circuit 0. This is open circuit. This is short circuit. Okay? I hope it's clear. Let's move on to the second type of the amplifier. Second type of amplifier. The second type is current amplifier. The current amplifier. Okay. So the base of the current amplifier is as follows. We have an RI. This is our source. RO. And here we have a current source that depends on AIS. II, and here's II. Okay, this is IO. Great. So as I said before, when they give you a question, you have to connect two things, the input and the output. This is the base of the amplifier. You need to connect two things, the input and the output. The output is simple. You only have to connect the load resistance, RL. And in the input, you have to connect what? It's either Thevenin or Norton. Here, it's a current source. It depends on a current. Therefore, we have to connect Norton. We have to connect the Norton equivalent and IS. Okay. Here we have the output, and here we have the input. Okay. Simple. If he asks me to find the voltage gain, what should I do? Current gain. What is the current gain? Current gain is AI, which is equal to IO divided by I input, right? Okay, and I said before that we need to start with the numerator, I output. Now try to give me an equation that relates I output with I input. What should I do? Of course, I'm going to do a current division. So I will say IO is equal to AIS II multiplied by RO divided by RO plus RL. Okay? And I need IO in terms of II, which is equal to, it will become AIS multiplied by RO over RO plus RL. This is the answer. And the unit is A over A. That's the current gain. But if they ask me now, find the overall current gain, we said before overall is what? Find overall current gain, the overall current gain is I output divided by IS. And as I recommended before, that you always need to start with the numerator, which is I output. Okay, now we need to reach from I output to IS. How can we do this? We have to break it into two steps. We need first to find I output in terms of I input, and then I input in terms of IS, and then plug into each other. Okay, let's do this. So I output in terms of I input, we already found it. I output in terms of I input, it's IO multiplied by AIS, II multiplied by RO plus RL. Okay, now we need to find II in terms of IS. II in terms of IS, we're going to do current division again. II is equal to IS multiplied by RS divided by the total. So it's RS divided by RI plus RS. After we have found II in terms of IS, we need to take all of this and plug it into II. So the final answer will be IO is equal to AIS open square brackets IS multiplied by RS RI plus RS, closing the square brackets, and then we can continue. It's RO plus RL. But the question was to find IO in terms of IS. Dividing the IS term will result the following. So this is the final answer. A over A. I hope it's clear. Okay, before we move on to the third type, let's find the ideal characteristics of the current amplifier. The ideal characteristic. We can play only with RI and RO. What should happen to RI so that the entire IS gets propagated to II? What should happen to RI? We have two options. It's either short or open circuit. Now, let's try to do a small circuit representing the short circuit and the open circuit. What's II in here? Now, whenever you have a short circuit parallel with the resistance disappears. So I will become, I is actually IS. So the answer is what? The answer is short circuit, right? Short circuit. Now, moving on to the second side of the circuit, the amplifier. Here's II. What should we do to RO? What should we do to RO? So that the entire II gets propagated to I output? Again, we have two options. It's either short circuit or open circuit. Let's try the short circuit. Okay. This is, I need to put here short circuit, and this is our RM. This is IO. What's IO in this case? We said whenever you have a resistance parallel with a short circuit, the resistance disappears. So actually IO has disappeared. It's no longer equal to I input. It has disappeared. So the answer is not, of course, short circuit. It has to be open circuit. Let's prove it. So here we have an open circuit, and we have our RL, and this is IO. Okay, so here, what is IO? There's nothing in here, right? So this current has the only path for this current is actually IO. So the answer here is open circuit. I hope it's clear. Moving on. Third type of amplifiers. The third type is transconductance. What's conductance? What is conductance? Conductance, the symbol of conductance is G, which is 1 over R. If R is V over I, then what's G? It's I over V, right? Okay. Now I will tell you what did I tell you this side note. What's the base of the transconductance? The base of the transconductance amplifier is as follows. I have an Ri in here. Okay. Gm, Vi, Ro, V outputs in here. Okay. This is I output. This is V input. Okay. So before you start solving or doing anything with this type of amplifier, you need to connect two things, the input and the output. We said the output, we always connect RL. And on the input, it depends on this. What is this? It's a voltage, so we have to connect the Thevenin form. RS with VS, okay? So here, what does the question say now? It says find the transconductance gain. What is the transconductance gain? The transconductance gain, first we need to understand the conductance. I told you it's I over V. And gain, as I mentioned before, whenever you hear the word gain, it's output over input. So now, as you have guessed, transconductance gain is I output divided by V input, because here we're having I in the numerator and V in the denominator. So where do we need to start? We need to start with I output, the numerator. Here, now try to find an equation that relates I output with V input. How can we do this? Yes, of course, both current division. So here it should be Gm Vi multiplied by Ro divided by Ro plus RL. IO divided by V input is equal to Gm Ro plus RL. Okay, so this is the solution. What's the unit? The unit is A over V. Now, if you ask me to find the overall transconductance gain, find the overall. What should I do? The overall transconductance gain is I output divided by Vs. You only change the V input. You will only change the V input into Vs. As I said before, the voltage gain, the gain by itself is output over input, but the overall is output over the source. Okay. Okay. So where should we start? We should start with the I output. I output in terms of V input, and then V input in terms of Vs, and then we substitute into each other. So IO in terms of V input is what? It's Gm V input multiplied by Ro over Ro plus RL. And V input in terms of Vs is voltage division. It's Vs multiplied by Ri divided by the total. It's Vs multiplied by Ri plus Rs, the total. Okay, so now we need to take all of this and substitute it where in the first equation here. Okay, so my equation will become I output is equal to GM Vs Ri divided by Ri plus Rs multiplied by Ro divided by Ro plus Rs. Okay, great. What's the unit? The unit is I over ampere over volt. Okay, what is last thing before we move on to the final type of the amplifier? What is the ideal characteristics? Let's use purple. Ideal characteristics Ri and Ro. We are only allowed to play with these two resistors because they are inside the amplifier. Ri, what should happen to Ri so that Vs can propagate to Vi? Ri should become open circuit, yes, open, infinity. And now what should happen to Ro so that Vi gets propagated to Vo? This resistance should be eliminated. So we need to do what? Open circuit, yes. Okay, last type of amplifier, and we will end this video. 4. Transresistance amplifier. Transresistance amplifier. Amplifier. Okay. So how does the transresistance amplifier look like? Looks like this. Ri. This should be given to you in that question. You should not know this unless the professor requires you to draw it, draw the base, but I doubt it. So this is the output. Here you have I input, okay, and here you have I output, okay. This is the input also. Transistance. Okay, so before we start attempting this question, we need to connect two things, right? The output, load resistance, and the input, we need to look at this. This is current, so we need to put the Norton form, Rs, with respect to, with an Is current source, okay? So the question says, find the transresistance gain. Find transresistance gain. What's the transresistance gain? Resistance. What is resistance? Resistance is V over I. Now, as they want a gain, then it should be V output divided by I input. Okay? It's V output divided by I input. Where should we start? We should start with the numerator, V output. Now try to find an equation that relates V output with V input. One equation. What should we do? We should do a voltage division. So it's Rm multiplied by Vi multiplied by RL divided by RL plus RO. Okay? So V output, here it should be I input, right? I input. So V output divided by I input is equal to Rm multiplied by RL over RL plus RO. Okay? So this is the answer. What's the unit? It's V over A. Make sure you don't get confused, by the way. V over A. Now Rm is not a resistance, it's a gain. So its unit is not ohm, it's A over V. Okay? Moving on to the overall transresistance gain. Find overall transresistance gain. Overall transresistance gain is V output divided by Is rather than the I input. So it's V output divided by Is where should we start? We should start with V output. Now, try to find a relationship between V output and I input. It's what? Voltage division, right? And then after we find this relationship, we'll move on to the second relationship between I input and IS, and then we substitute. Okay, so V output is Rm I input multiplied by RL divided by RL plus RO. Then II in terms of IS is current division. II is IS multiplied by RS divided by the total. It's IS multiplied by RS divided by RS plus RI. Okay? So now we need to substitute this entire thing into II. So what's the output now? It's Rm with IS RS RS plus RI with RL RL plus RO. Okay, dividing by IS will result in Rm RS RS plus RI multiplied by RL RL plus RO. Okay, that's the final answer. What's the unit? The unit is V over ampere. Finally, let's talk about the ideal characteristics. What should happen to Ri and Ro for the amplifier to become ideal? Ri and Ro. Okay, so we need this entire current to be propagated to II. What should happen to Ri? Short or open? It should become short circuit, so we can eliminate Rs, short circuit. Okay, now what should happen to Ro so that this entire voltage gets propagated into the output? Ro needs to become a short circuit, because if you make it an open circuit, then you will lose the current and RL will disappear. So here it has to be a short circuit. Okay, so I guess here we have finished the first part of chapter 1. In the next video we will start the semiconductors. Thank you for listening. If you enjoyed this video, please like and subscribe this video so I can continue with my work. Thank you.